As we go into the last section in topic 2, or in chapter 2 that we'll cover, is topic 4, dealing with linear inequalities. Now, an inequality is a statement that tells whether something is more than or less than other things. And here are some examples of it. This would be an inequality where the symbol is in the center. And here is sort of a compound inequality where the inequality is in the middle of two inequality signs. Now, when we solve inequalities, much of the rules that we use for solving equations are there as well. But I'm going to give you some general background items about our 4 inequality signs, and I'll set that up for you. So here are the 4 inequality symbols that we work with. Reading the first one, x is less than 2. X is less than or greater than 2. Less than or equal to 2. X is greater than 2. X is greater or equal to 2. Now, often we are asked to graph an inequality, so I've set up a portion of a number line for each of these, and the number we're interested in is 2. Now, to put this on a graph, x is less than 2, we would use a parenthesis that faces to the left, and we would darken this line and put an arrow there. So this is going to negative infinity in this direction, or coming from negative infinity up to 2, but 2 is not included in the set. For this next one, x is less than or equal to 2. Now 2 is included in the set. When a number is included, we use a bracket. And this part is the same. It's coming from negative infinity going up to 2, but 2 is included in the set. X is now greater than 2. So again, 2 is not included. We use a parenthesis and then an arrow indicating it's going up to positive infinity. And here the only difference is that 2 is included, so we use a bracket. So these are the graphs of the inequality statements. Now, another item that we will use is interval notation. Now, once you have an inequality in its graphical form, interval notation works very well, because where is this coming from? And we use, as we mentioned before, a parenthesis for negative infinity going up to 2. And right from the graph, 2 is not included, so we use a parenthesis. Here we're going to use from negative infinity going up to 2, and 2 is included now, so we use a bracket. And for this one, it's coming from 2, but 2 is not included, and going to infinity. And infinity always ends or begins with a parenthesis. and here we'll use a bracket going to infinity. So these are common ways to express inequalities: the statement, the graph, and interval notation. And I'm assuming you're putting this in your notes. This is going to be good background information. Again, we will be going over these rules. They are summarized there. Now, we do have a caution about when we are doing inequalities. The one difference that we find from solving equations and inequalities is this, and I'll illustrate it for you. We know that 2 is less than 4. And if we multiply 2 on this side by 2, and on this side by 2, we get 4 is less than 8. So this is still a true statement that we can multiply both sides by something, in this case a positive 2, and it's true. But how about if we multiply both sides by a negative 2? We then get a negative 4 is less than negative 8. That is not true. So we have the rule that whenever we multiply an inequality or divide an inequality by a negative, to make it a true statement, we have to reverse the direction of our inequality sign to keep it true. When we multiply or divide by a negative, we have to reverse the sign of the inequality to keep it true. Otherwise, it becomes a false statement. That's the only caution when working with inequalities. So let's go on and do some now. So here's a pretty standard inequality statement. We're going to transpose the 5 to get it on the other side. So we have 3x is greater than 6. On this side it becomes a negative 5. We're going to then divide both sides by 3. So we get x is greater than 2. And they do have the work there. And we did this graph already. Note that you would use a parenthesis at 2, indicating that 2 is not a member of the set. And interval notation, parenthesis, starting at 2, or just beyond 2, 2 is not included, going to positive infinity. Now the book shows it a certain way. I'm going to show you another way that it can be done. I mentioned before it's always good to keep your x values positive. So I'm going to move the negative 3x to this side, where it becomes a positive 5x. I'm going to move the 7 to this side, where it becomes a negative 3. So this would be a negative 7 on this side, plus 4 is a negative 3. Now I'm going to divide both sides by 5. I can then write negative 3/5 is less than or equal to x. Now notice I didn't have to change the direction of my inequality sign because my x's were positive, and I divided by a positive 5. In the textbook, they're doing it a little different way. They're moving the 2 x's over to this side, and then the 3 is over there. So when they solve this, as you see down here, they're going to divide by a negative 5. And in order to keep that statement true, they would have had to reverse the direction of that inequality sign. Now notice they get the same answer, but here you'd have to read it from the right to the left. Here you're reading it from the left to the right, but it's still x is greater or equal. So a little technique that you may or may not want to use, trying to keep your variable positive, and that way not having to reverse the sign by dividing by a negative. So they are showing here the reversal of the inequality sign, and there's your same statement. And they show it in interval notation as well as the graph. My question to you, why are they using a bracket there? Because your inequality sign also includes the equal to, indicating that this value is part of the set. All right, let's go on to example 3. And I'll set that up over here as well. This is a compound inequality where the inequality is in the center of 2 inequality signs. So here I would suggest, instead of transposition, using this older technique, you want to isolate the m. So you start off by getting rid of any number that's there. So I'm going to subtract 5 here, subtract 5 there, and I would have to subtract 5 there, and we don't have an x there. Okay. Now when we add this, this becomes a negative 7 is less than 3m is less than 15. So the technique of doing it this way to each part, I think, is a good technique. Now to solve for m by itself, we're going to divide each term by the numerical coefficient of m, which is 3. So we then get a negative 7/3 is less than m is less than 5. And that's what we get here. So I like it this way. Here they're doing it horizontally, and that's okay too. Now to graph it, this is the negative value you're interested in, and you're going to use a parenthesis there and a parenthesis there, and you're filling it in between the parentheses. And interval notation right from the graph, a parenthesis, a negative 7/3, comma, and then a 5 and a parenthesis. Again, the use of this diagonal line there to indicate fractions, we don't like that too much. Okay. In this one, they're asking you to use the formula for converting Celsius to Fahrenheit temperature is this. What Celsius temperature range corresponds to 32 to 77? So basically you're going to say the Fahrenheit range, where it begins at 32 and ends at 77. Keeping in mind this is the formula of what Fahrenheit is. So you put this formula in the middle. There is your range. And again, 32 is not going to be included. 77 is not to be included. So a technique to solve this, as we mentioned, would be to subtract 32 from this, and from this. And that's what they're showing here. Okay? Now, let's pick it up from here. Now, we want to solve for C in the middle. So, a technique that you may or may not recall, how do we get rid of 9/5 and make it a 1? Well, the answer is we multiply it by its reciprocal, 5/9. But then we have to multiply each of these by 5/9. We're doing the same to each part of our inequality statement. So here, this is still just 0. Here, everything cancels out and you're left with a 1C that we don't write. Now here, 9 goes into 45 5 times. 5 times 5 is 25. And there is our answer statement right there. Going on now to a word problem giving some background. It says a company will only produce a profit if its revenue, R, is greater or equal to the cost. So here they're telling you a company analyst has determined that the cost to produce and sell X units of a certain product is this. So this is sort of like the cost function. Cost is this. And the revenue is this. So the break-even point on profit of a product is what? Well, it would be revenue is greater or equal to cost. So there's our revenue, which we're substituting R for this, and our cost, we're putting this there, and that's our inequality. So we subtract 20x from both sides, divide by 50, so you would have to sell 20 items or more in order to break even or to make a profit. All right, example 6 is similar. Let's take a moment to read it. So after reading it, we see it's a very similar problem. Your revenue, when you sell a bag of pretzels, it's 35 cents for each bag. You have cost, which are fixed cost and variable cost. Your fixed costs are 110,000, and to make each bag of pretzels, its materials to make that bag is 0.25 or 25 cents. So revenue still is greater or equal to cost. You set it up. So the manufacturer has to sell over 1 million bags, there's the specific number, in order to make a profit. All right, we're also going to at this time introduce absolute value inequalities. So as we do this, I will set up a little pattern for you of how to do them. Okay, the pattern for doing this, there's your initial statement. The absolute value of x is less than 5. So again, as we did earlier in the course, the absolute value, we take it away and just say x is less than 5. Now we have to write it again. We usually put the word or there, or x. Now we reverse the sign, the direction of our inequality, to greater than, and then change the sign of our 5 to make it a negative 5. So this is the results. X is less than 5, or x is greater than negative 5. So how do we put that on a graph? Well, at our negative 5, we're saying x is greater than negative 5. So the parenthesis would go this way, and we're going to sketch it in. I'm not going to go all the way yet, because we then do this one and say x is less than 5. We put a parenthesis this way, and our line then goes and fills in between. So there's our statement. This is the graph. Now how would we write that in interval notation? Well, right from the graph, negative 5, comma 5. Now they're going to show us this on the next page, but I wanted to give you a quick introduction here of what's going on. Now, whenever you see absolute value and the sign is less than, the graph is going to look like this. A little later they're going to reverse this, and it's a different kind of graph, as you'll see. Let's go on. So there's the graph of the previous one. X is less than 5. But now we see the absolute value of x is greater than 5. So again, you write it without the absolute sign. Write it without the absolute sign for the next one. Reverse the direction, and it becomes a negative 5. So when you graph this, we'll do this one first. X is less than negative 5. Will be a parenthesis facing left. And this one would be a parenthesis facing right. And there's the graph down there. Now the interval notation for this, they're saying is this or this. Now we often use, instead of the word or, we use an upside, well, a U, kind of an interesting U, which is a union sign. It's this in union or with this. So I don't recall exactly how this is going to be shown in Math Lab, but this is the difference. So if it's this type where you have the inequality less than, you have this type of graph. If it's x is greater than, let's say 5, you're going to have this type of graph. So the greater symbol indicates there's a space between things. A less than symbol, it's between the two signs at the end of your line. All right, a little something and you'll be practicing this. And in this bluish box, they're giving you a summary of what we've just done. Now, how about if it's a little more complicated? How do we do that? Well, keeping in mind if it's less than the absolute value, you just put the absolute value between two inequality signs like so. So we know the results are going to look like this somewhat. And then we use the technique of adding 2 there, adding 2 there, adding 2 there, and then that's our answer. So again, with an inequality sign like this, less than, we just take our absolute value and put it in the center. Now notice this is reversing the sign for this end. And again, if you know this is the pattern, this is what you would do. Now, for something like number 9, we have to isolate the absolute value portion first by adding 1 there, adding 1 there, then we get this. Now, since this is a greater than, it'll be an or statement where you have it written this way. And notice you had to, this is this one up here. This one you had to reverse the direction of the inequality sign, right there to there, and put a -5. Okay? You solve them separately, and this is what you get. And keep in mind, these are parentheses, and it will show a break between them. I don't see them using the word, but we call this a disjunction. I'm not sure why they're not using it, but I don't want to cloud what you're doing with words that you're not going to be using. Now, example 10 is a little tricky, and it's super critical of what your inequality sign is. So if your inequality sign for something like this is greater than or equal to a -8, we say that normally if this were less than or equal to, that is the opposite of this, there would be no solution, because our absolute value needs to be positive. But if they start with a -8 and it's greater than, then it's going to be all real numbers. And this is the statement here that describes what we've just said. So read this over. This is sort of a unique condition, because we said if we just had a absolute value was equal to a negative something, that would be no solution. But if it's greater than or equal, it's all real numbers. But if it's less than or equal, it's no solution. And you'll be doing some practice, and good luck on your Chapter 2 test.